So a friend and I are hiking in the mountains, and we want to climb a ledge that's 22 feet above me. Now the height of the grappling hook that I throw to try and climb up that ledge is given by the function h of t is equal to negative 16t squared plus 32t plus 5. Because I mean, just like throwing a ball, I'm going to throw it up, and it's going to fall down. So I need to know that at what height is the grappling hook thrown from, what point could that value represent, what's the maximum height the grappling hook reaches, can the grappling hook even make it to the top of the ledge, and how high is the grappling hook at a certain time. So it looks like I should probably just go ahead and graph this in Desmos so I can take a look at the picture and see what exactly is happening here. So I've got my output is equal to negative 16 times my input squared plus 32 times my input. Oh, wow. There we go. And plus 5. So here's my graph. It looks pretty close. So I am going to go ahead and change the values of my table for my x and my y axis. And here we are. So I've got my graph. And it says at what height was the grappling hook thrown from. So again, this would be my y-intercept. It looks like my hook was thrown from 5 feet above the ground. I can see that in my equation as well. It was, again, 5 feet above ground, and that's going to be my y-intercept, because that's the starting value. That's where the hook starts at. Now, if I want to know the maximum height, I need to look at the maximum of the graph, and it looks like I reach a maximum height of 21 feet. So the grappling hook makes a maximum height of 21 feet in the air, and so since the ledge happens to be 22 feet tall, and I can only throw it 21 feet in the air, no, I cannot reach the ledge. So since the hook misses the ledge, how long does it take for the grappling hook to hit the ground so I can try again? So that's going to be, again, how long. So I'm going to take my starting value of 0.5, and it looks like the input for time is 2.146 seconds later. I'm at a height of 0. So again, I reached my maximum at the 1 second mark, but 2.146 seconds later, my grappling hook has hit the ground again. So after 2.146 seconds, I can try and try again. When I ask for a height given a specific input, we're going to go back to Desmos, we're going to make a table, we're going to plug in that specific input, and we're going to get that specific output. Oop, not 0.8, I want to know 0.8. And when I plug in 0.8, I get a very specific output of 20.36 feet. So again, graph your equation, make sense of it based off of the scenario you have, find the starting value, the y-intercept, find the ending value, find the maximum, and interpret what they all mean in the context of the problem. I'm given an equation, negative 0.06x squared plus 0.96x, and it models the height of the winning long jump at a middle school track meet, where x is the distance in feet from the beginning of the jump. So I've got horizontal distance and vertical distance. I'm just going to go ahead and graph it, so that way I can see what we're talking about here. So y equals negative 0.06 x squared plus 0.96 x. Notice how there's not a constant at the end because I don't start higher. Like I'm literally jumping from the ground. I'm jumping from the ground, I'm landing on the ground, and somewhere along the way I reach a maximum height. So it wants to know what's the length of the winning jump and what's my maximum height. So the length of my jump is going to be from one x-intercept to the next. So that winning jump is 16 feet. And then my maximum height, again, is going to be the y value of my vertex. And it looks like I am 3.84 feet above the ground. So 3.84 feet is how high I got. Obviously, maybe that's not the highest jump overall if we're measuring like from the top of my head or something, but we made it pretty far. If we look at number 12, the equation h of t is equal to negative 16t squared plus 12t plus 4 can model the height in feet reached by the coin tossed by the referee before the game. Now, why do we even care about how high the coin gets tossed by the referee before the game? Maybe we don't even care at all. Personally, I don't. So we're going to answer these silly questions anyways. Sorry for making you do this. The time in seconds is represented by t. Use your calculator to answer all parts to this question. So, say less. We've been using our calculator all day, son. All day. So y is equal to negative 16x squared. Oh, forgot the equal sign. Uh-oh. Plus 12x plus 4. And there we go. We got my coin toss. That coin starts 4 feet above the ground. It reaches a maximum height of 6.25 feet above the ground 0.375 seconds later. And it hits the ground 1 second later, which is 0. So I've got my graph. I'm going to use it to answer my question. So here we go. The initial height of the coin, or the y-intercept, boom, 4. How high is the coin half a second later? We want a specific output based off of a specific input, so let's plug in that specific input, and half a second later, I'm 6 feet in the air. It wants to know the maximum height, so I need the maximum y value. So when I take a look at my graph, if I want the maximum y value, I'm going to click on it. The maximum height is 6.25 feet. When does it reach the ground? Looks like my graph hits the ground again, or hits my x-axis again, a full second later. So at time equals 1 second. Then it wants to know what is the interval that the coin is falling towards the ground. So from what time is it decreasing? And so it looks like from 0.375 seconds all the way to 1 second, we are decreasing. My graph is going down from an x input of 0.375 all the way to 1. So the interval of decrease is 0.375 seconds to 1 second. And there's my interval of decrease.